Hello ladies and gentlemen, today we are talking about lesson 7.2, which is using the converse of the Pythagorean theorem. To illustrate that, let's take a look at some geometry software. And I've created a right triangle here. As you can see, it's a right triangle because there's a 90-degree angle. And I made an expression, c squared and then a squared plus b squared. And you can see that from this picture, c squared is 335. And a squared plus b squared is 335, and that's using those numbers up here, so it already calculates it for us and shoots it down there. So in a right triangle, we know that this is true. The converse of the Pythagorean theorem says that if this is true, you have a right triangle. So if this is not true, the inverse, then this is not a right triangle, or the contrapositive, I should say. So if I were to make this something else, not a right triangle, let's do this. I made this an obtuse triangle, so obviously these are not equal anymore. So the converse says if c squared equals a squared plus b squared, then it's a right triangle. Well, here I have an obtuse triangle, and c squared is greater than a squared plus b squared. What do you think would happen if I made it an acute triangle? C squared is now less than a squared plus b squared. So the relationship between c squared and a squared plus b squared can tell if it's a right triangle when they're equal, if it's obtuse when c squared is greater than, or if it's acute when c squared is less than. And that's the focus of today's lesson. We have three different theorems here, 7.2, 7.3, and 7.4. The first one, 7.2, is really the converse of Pythagorean theorem. It says if c squared equals a squared plus b squared, then c is 90 degrees and ABC is a right triangle. Theorem 7.3 says if c squared is less than, then it's an acute triangle, and if it's greater than, it's obtuse. That's 7.4. So these are basically the summary of what we'll be talking about through our example problems today. Go ahead and pause it if you'd like to copy these down. Otherwise, I'm going to proceed to the first problem. Maybe. Oh, there we go. Okay. Tell whether the given triangle is a right triangle. So for the first one, we have three angle measures, and we'll use our Pythagorean theorem. And if this is true, then it's a right triangle. If it's false, it's not a right triangle. We can't assume it's a right triangle because we don't know if this is 90 or a right angle, or if these are perpendicular. We don't know that, so we need to use our Pythagorean theorem converse to test and see if it's a right triangle. So C, this appears to be our largest angle, so this would make this our largest side. So that would be our hypotenuse. So our C is 3 root 34. And A and B are 9 and 15, the order of which doesn't matter since we're using addition. And to simplify our radical, we can distribute our exponent because we're multiplying inside our parentheses. We're not adding or subtracting. If we were adding or subtracting, we cannot distribute this exponent. So this will distribute to be 3 squared, and the square and the square root will cancel, so we just have regular 34, and that's going to equal 81 plus 2, 25. We know that 3 squared is simply 9, so I'll erase this and use 9. And if we multiply this, we end up with the product of 306. And on the right side, 306. Since these are equal, that means that c squared equals a squared plus b squared. So yes, this is a right triangle. Similarly, with part B, we'll use our Pythagorean theorem again, really the converse. And our largest side is 26, so that's our hypotenuse, and then 14 and 22. So I'll square all of these and add them together and simplify to see if this ends up being true. So 26 squared is 676, and 14 squared plus 22 squared is 680. Well, since these are not equal, this is not a right triangle. Did those? Let's do something slightly different. Can these segments form a triangle, period? If they can, is it acute, right, or obtuse? Well, for honors, we discussed this topic in Chapter 5. For regular, we did not discuss this since we did not do Chapter 5, so I'll go through this at length. The first thing to do is test if it can form a triangle. If it can form a triangle, then we should be able to add our two smaller sides, and it should be greater than our largest side. If this is true, then yes, those sides can form a triangle. If it's not true, they will not form a triangle. You may be asking yourselves from the regular classes, what do you mean it can't form a triangle? Well, if I have one side, let's say that this is 1, let's say this one is 5, and this one is 2. I should probably draw this a little bit differently to make this accurate. It's impossible for this side and this side to ever touch because they're too short. So because they're too short and they'll never touch, this triangle can never be completely formed. There will always be a gap up here. So in order to test if three numbers can form a triangle, which these three cannot, we'll take our two smaller sides, and when you add them together, it should be greater than your largest side. If that test is failed, then those three lengths cannot form a triangle. So in this case, if I add 4.3 and 5.2, I end up with 9.5 as my sum. That is greater than 6.1, so yes, it can form a triangle. Since it can, let's see what type of triangle it forms. So we'll use our Pythagorean converse. I don't know if it's going to be equal, if it's going to be greater than, or if it's going to be less than. So I'm just going to leave it blank. And we'll find out what's going to go there. So my largest side, C, my hypotenuse, is 6.1. A squared and B squared are 4.3 squared and 5.2 squared. If I simplify these, 6.1 to the second power is 37.21, and 4.3 to the second power plus 5.2 to the second power is 45.53. Well, in this case, C squared is less than A squared plus B squared, so this is an acute triangle. Let's look at another example. And let's try number 2 first. So first, as the directions state, we need to find out if they can form a triangle. So our largest side here is going to be 6. For the square root of 8 as a decimal approximation, it's a little bit less than 3 if we were to check that as a decimal. So we need to see if we add the square root of 8 and 4, it should be greater than 6. And if we add, the square root of 8, which is about 2.8, and 4, this is about 6.8, and yes, it's greater than 6, so this does form a triangle, so let's see what type of triangle it forms. Using our Pythagorean converse, 6 squared is either equal to, greater than, or less than the square root of 8 squared plus 4 squared. And 6 squared we know is 36, and the square root of 8, and if we raise that to the second power, our square root and our square will cancel, just like division and multiplication cancel. And 4 squared is 16. So we have 36, and 8 plus 16 is 24. Since 36 is greater than 24, this is an obtuse triangle. Let's do one more, just for the kicks and grins here. Let's do, let me see which one is going to give me a problem that I would like. Let's do number 5. First, let's check and see if this can form a triangle. So if I add the square root of 13 and 10, that's not going to work.